important. But today we're just going to kind of build off of what we saw yesterday, and we're going to look at dividing radicals. It's very similar to multiplication. You can only divide if you have the same like radical or the same index number. Like you have to have like a cube root and a cube root. Eventually we'll look at how to mess like if you don't have the same types of roots, but for now, basically to do things like these, you want to make sure they have the same roots. Just like with multiplication, basically you're just going to divide what you have underneath your radical signs. So since these are both square roots in this first example, basically you're just going to make one radical and you're just going to divide each part. So like 18 divided by 2 would be 9. Remember when you divide like x's or powers, you subtract. So 5x's minus 3x's would be 2x's. And then if you square root this, this one works out really nicely. The square root of 9 would be 3. The square root of x squared would just be x. Because remember with the variables, with the square root, we don't write it, but remember your index number is a 2. So basically how many pairs of 2 can you make out of 2x's? Well, 1. And since you don't have anything left over, you don't have a radical part. So same idea with this next one. If it's a cube root divided by a cube root, you can do that. So you're just going to have one cube root. So 162 divided by 3, what is that? Okay. So like 61, I think that was right. Okay, and then like same idea with your variables. Like I said, you're subtracting, so you'd have 3 y's. And as you can see, this problem works out pretty nicely as well for the variable part. For the 54, my advice is you could do a factor tree or think of perfect cubes that divide into 54. And I mean, it might be helpful to kind of write a list of perfect cubes when you're looking at the problems in Delta Math, but like our perfect cubes, like 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, which is too big. Screen, so it's out of the way. So you always want to start with the biggest one. 27 does go into 54 though. So I know this is a little bit sloppy because I write too big, but basically the cube root of 54 would turn into 3 and cube root of 2. I should leave a little bit of space though. And then for your variable part, like the cube root of y to the 3rd power, you would just pull y to the outside, because how many groups of 3 can you make out of 3 y's? Well, 1, so you pull that to the outside. So your final answer would be like 3y on the outside, cube root of 2. For C, if you divide this, that would be 25. Subtract, you get x squared. So this one simplifies really nicely. Like these problems are actually working out really nice. You're probably going to see some in Delta Math that you'll have to do a little bit more thinking, but this would just be 5x. So that's division. So it's pretty much the same idea as multiplication, just basically work out what you have underneath your radicals. And then once you get your quotient, see what you can do to simplify it, like simplify your number part, like or your coefficient part, and then simplify your variables. So kind of putting together a lot of the skills we've seen like in 6-1 and so far with radicals. So I mean, if you've been doing well with what we're doing, this shouldn't be too bad. But if you are having issues, just make sure you ask questions, because a lot of it is building on top of what we've seen. So I know sometimes if you kind of miss something, you can kind of feel like you're kind of lost or kind of fall behind. The last thing we want to talk about, and I'll be honest, this is something that's probably getting less and less important over time because of computers and stuff. But back in the day, before like calculators and computers were really all over the place, a lot of times it would be really helpful if you could write your solutions or your final answers without radical on your denominator. So this process is called rationalize your denominator. And the reason I'm showing you this is a lot of times on like standardized tests, Or you might just have a teacher that's like, you've got to rationalize the denominator. Um, a lot of times they're going to put their multiple choice answers with their denominator rationalized. So it's a helpful thing to see. And when you're doing like trig stuff, well, I'll try and show you a little bit of that hopefully before the end of this year. But next year, you'll be doing quite a bit of trig in your spring class if you are doing like the 1530 pathway. So one thing when you do something called a unit circle, sometimes they rationalize the denominator, sometimes they don't. It kind of depends on your teacher or where you're looking at. So um, it's one of those things, you just do it because you're supposed to do it. But I'll be honest with you, I mean, in my opinion, I really wouldn't care if you left an answer with a radical on the bottom, but that's just kind of my personality. I don't know. So basically, like I said, what our goal is when you see a problem where it says rationalize your denominator, basically your goal is to get rid of a radical on the bottom of your fraction. So all these problems we're looking at today are, it's like with just like a monomial on the bottom, it's just like a single number. It does get a little bit more complicated if you have like, say for example, you had the square root of x plus 2 on the bottom, then you'd have to do like a conjugate, which we kind of talked a little bit about when we were looking at complex numbers. But I'm just going to kind of show you these basic ones. Maybe next year you'll look at with binomials. But basically, to rationalize your denominator, you just multiply the top and bottom of your fraction by your denominator. Because basically your radical 6 over radical 6 is really 1. So I'm not changing my problem when I multiply by radical 6 over radical 6. Like, this is fair game. I'm not changing my problem. I'm just modifying it using this kind of trick. But it's still the same exact value, what we're coming up with. So your bottom, one tip, when you multiply the square root of 6 times the square root of 6, one tip, that's going to be 6. Like anytime you multiply a square root times itself, you just get what's underneath. Just be careful if you have different types of roots, though, it is a little bit different. Like with a cube root, you would actually need 3 of them. So just kind of keep in mind, if you have whatever your index number, that's how many x's you're going to have to multiply under a radical to get rid of itself. So I think there's 1 cube root on the sheet we'll look at. But and then our top, the square root of x times the square root of 6 would just be the square root of 6x. And then you always want to check, can you simplify? And in this problem, we can't. Like, there's nothing you can really do with that radical 6x, but a lot of times you'll be able to simplify what you get on the top. So this one we can't, but keep in mind on most of these problems, you're going to come across a lot of times you can simplify what you're going to get on your numerator. So this is, like I said, this is called rationalizing your denominator. Basically, like I said, only what your goal is or what rationalizing means is basically you just get rid of the radical on your bottom. Because some people prefer this because this is something a lot of times that's easier to deal with if you're not really using like a computer or a calculator. But honestly, I mean, we're kind of getting to a point where it's really not as big of a deal as it may have been like 100 years ago. So, I mean, but it's still something a lot of standardized tests show your answers in this form. So, because for example, you might get like this is your answer, but this is what they're going to put on the test, like for the choice you'd have to pick. So just kind of recognizing and understanding, oh, they probably rationalize the denominator is what I want you to see. Keep in mind for B, anytime you have a radical part, like a fraction under a radical, you can always rewrite it with like the top is a square root and the bottom is a square root. Like you can kind of separate them. But then to rationalize this, we would just multiply by the square root of 2, square root of 2. So the bottom is just going to be 2. But the top would be the square root of 18x. But this can simplify, like you could pull out a, what does it? Oh yeah, you could pull it a 9, don't we? So this would really be 3 square root of 2x. Because the x you can't do anything with. So that's kind of the idea with these. I don't think I'm going to do them all. I'm pretty sure in delta math you're only going to see square roots too. So I'll probably do D so you can just see it. But for this one, same idea. So the bottom is just going to be 2y cubed. So like the bottom is always easy. It's the top that you're going to have to usually do more with, but this would be 36 x squared y to the fourth. This does simplify really nicely though. The square root of 36 is 6. The square root of x squared would just be x. The square root of y to the fourth would just be y squared, and then you don't have anything left over, so there's no radical. So actually this one you can simplify quite a bit actually. You could divide the 6, that would 6 by 2 would be 3. The x is going to stay the same. One tip with the y, if you subtracted this, you would get -1. But remember, if you have a negative exponent, you can flip it over your fraction. So a lot of people can just jump from here. Basically, you just subtract your y's from like the bigger one. Like you can also kind of like subtract from the bottom. I don't know if that makes any sense, but a lot of people, like this is like how you would probably have to think about it formally, but a lot of people, you can kind of just skip this middle step here. Oh, and sorry, I was looking at the chat. Walk forward. That was, let me know if that makes sense. Oh, and we got just a heads up, Mrs. Hager's popping in. This must be for like a walkthrough. So just a heads up, guys. Okay, so that's how you do square roots. So like I said, I'll double check. I could be wrong, but I don't think you're going to see any cube roots in Delta Math. But if you do see a cube root or a different root, basically, instead of just multiplying the bottom by one of these, you have to multiply it by 2 of these, because basically to like cancel out a cube root, you need, this is getting sloppy. You basically need to have 3 of these. Like instead of 2, like a square root, you need kind of 2 things to cancel out. For a cube root, you need 3. If this was a 4th root, I would add 1 more. You know, like if this was it's not a 4th root, but so these get a little bit messier. I'm not gonna lie. Like, I mean, obviously you're gonna have more to do, or more to simplify in the top when you're finished with these. But I mean, the process itself is the same. Sloppy even for me. So on the bottom, like it basically, you're just going to get what's underneath the radical. So the bottom's like when you're rationalizing a denominator, your bottom's always like not a problem. It's then what you get on the top that you need to make sure you simplify. So basically, you would just multiply all of these out. So 7 times 4 times 4, that would be 7 times 16. So that would be 70. 7 times 6 is 42. So that would be 112. Plug that in just to make sure. 7, yeah, it is 112. And then your x's, if you look, you've got 1x, you've got 2, you've got 2. So altogether you'd have 5. And then you still have those 2 y's from the original. Oh. Okay, I'll just rewrite it. So it's at 5x's. And then you just want to see if you can simplify this. So obviously when you have a cube root though, since you're multiplying by multiple radicals, like you're going to get more stuff underneath the radicals. So usually there's more to simplify with. So it's not harder to do cube roots, but a lot of times it does turn into more work because usually there's more to simplify with what you have on the top. So like I said, you want to think of your perfect cubes. And you might just kind of want to write these like on a piece of paper. Oh, I forgot 27. 25. So once you, I mean, it's never going to be bigger than this. So does 64 work? No. No, 64 doesn't work. Does 27 work? 27 doesn't work. Does 8 work? 8 does work. So you can pull out an 8 from this. So I'm just going to kind of do it on the side here, but this would be the square root of 8, or not the square root, sorry, the cube root. So that would really turn into a 2. I'm just going to write it below. Bottom's going to stay the same. And then for our variables, I'm just going to write, it would be a cube root of 14, because you can't simplify a cube root of 14. For our variables, how many groups of 3 can you make out of 5x's? Well, you can make 1, but you're going to have 2 left underneath. For the 2y's, you can't pull out any because you can't make a group of 3. So I know this is sloppy, and like I said, I'll make sure I upload my neater key, but this would, so our final answer would be 2x cube root of 14x squared y squared all over 4x squared. So like I said, I'm not going to be a huge stickler with rationalize your denominator, but it is important that you kind of at least understand how this process works, because like I said, on standardized tests, a lot of times if you get like a radical on the bottom, they're going to rationalize it. So when you look at your multiple choice options, you might not see what you got. So if you don't, be like, oh, maybe they just rationalized the denominator. Second, when you're taking trig next year, or when you're doing trig, whether you're in honors pre-calc or if you are on the 1530 path, you're going to see when you're doing a unit circle, sometimes some books or some teachers will like show you things on something called a unit circle with rationalized denominators, some won't. It kind of depends on your teacher. So I figured I'd show you because this could be helpful to you in future classes. But for me, honestly, if you're taking a test and you get a radical on the bottom and you leave it, I don't really care, because like I said, with computers and stuff, it's not as big of a deal as it used to be. So that's it for our notes. Oh, yeah, actually, good point, Brooklyn. Yeah, you actually could simplify this a bit more, like with what you have on the outside. So yeah, but yeah, you really should. So like 2/4 would be like 1/2. And then your x's, like basically you have 1x on the bottom if you canceled out one of them. So yeah, technically this like I said, if this was like a standardized test, this would probably be the final answer. Like they would simplify it as much as they possibly could. So yes, good catch there. And like I said, I'm going to skip E and F. I'll put up a key. I mean, E is really not anything fancy from what I'm seeing. F would honestly be a pain because it's a 4th root. You'd have to multiply it by like 3 extra radical parts. So the process would be the same, but that one would probably honestly be a pain to simplify with what you get, all the stuff you get on the top. So that's our notes, and I will make sure I upload like the Zooms of these videos. Let me just make sure I stopped